Assalamualaikum dear students, I hope everybody is fine. I am Dr. Alives and you are watching YouTube channel Alevelcams. In this lecture we will discuss the gradient of a curve. To make understanding with the gradient of a curve, consider a curve. Let's say this curve is f of x and a line that is a tangent to the curve at the point of contact P. Let's say this line is y is mx plus c, line is of the form y be a curve, and this line is tangent at the point of contact, where m is gradient of the curve, is the gradient of curve at the point of contact P. So to make understanding with it, we consider an example. Let's say the curve is y equal to x square. So this is the curve. So I take different point over this curve. Let's say the origin, the 1 point, the 2 point, and 3 point. So I've tried to find the tangent line at the point of 3 9. Let's say this is the point of contact and I'm interested to find the tangent at that point. So I consider a chord from point P, an origin, and a chord from P, and let's say this is Q. So the gradient is defined as difference between the y and difference between the x, which is 3. Now I calculate the gradient of point PQ. If Q is 1 1, so you have 9 minus 1, 3 minus 1, 8 by 2 is 4. Now I consider gradient PQ. Consider Q is the point 2 4. You have 9 minus 4 and 3 minus 2. You have 5. So students, you can see that actually we are interested to find the gradient at the point P39. I started to find the gradient of the chord from 3 0, 3 1, 3 2 and so on. I want to move near to the point Q. So you can see that as well as the point is moving towards the Q, gradient is increasing. So if I take the point here, let's say I choose the point Q, which is 2.7 and 7.29. So gradient of PQ, since P is fixed, calculate the gradient. 9 minus 7.29 and 3 minus 2.7, you will get 5.7. And if I take the gradient between the point PQ, where the Q is 2.8 and the square of 2.8 is 7.84. The gradient, when you will calculate, it is 5.8. Similarly, if you calculate the gradient of the point Q, where I take Q point more near to the 3, you will see that its gradient will be 5.9. It means as well as we are moving towards the point Q, means you are taking over the fixed x for the P naught is 3. I choose firstly point 0, then 1, then 2, 2.7, 2.8, 2.9, means I am moving towards the point 3. I started from 0 and I am moving towards the point 3. As well as my x approaches to the 3, the value of the gradient is also increases. So I can observe that since the gradient is also increases depending on the x, so its value is also approaches to 6, it seems. So when you take more near value, let's say 2.99, you have a gradient near to 6. So it means you can write from here, when point Q approaches to P, the chord approaches to tangent at the point of contact P. So it means, in another words, you can write when x approaches to 3, also the tangent approaches to 6. So student, you can see that this gives us the limiting concept of the variable x. Let's say when you said x is approaches to 3, it does not mean x equal to 3. It means that the difference between x and 3 is very small. Let's say 0.0001 or maybe smaller than this one. So we write it in generally, the difference between the point is very small number, which is h, where h is approaches to 0. So when you zoom out, you will see that there exists some distance between x and 3. But in a roughly speaking, you said that when x is 3, the chord approaches to the point Q. So one point is to be noted here. The limiting approach also create a wall between the algebra and the calculus. Basically, the limiting concept is the starting of the era of calculus. In a YouTube video, maybe you have seen that there is a sea in which the blue and brown water are together, but they are not mixed up to each other because there is a wall who separate the brown water on left and the blue water on the right. So it is the same as we can have the idea of algebra and calculus. When the limiting concept included, then the algebra and calculus become separate by the wall. This wall is basically a limiting concept. Now we use the limiting concept to find the value of gradient for any of the general curve. The example over which we are working for the curve y equal to x square, let's say this be a point P point which value is 3, 9, and this be a Q point. You remember that we have such a graph y equal to x square in which this is point Q, here is point P. So we are taking point Q closer to the P. It is not necessary that you can use the point P from this direction. Maybe you can choose the point Q here and you are moving towards the point P. In any of the direction which is suitable for you, you can use. For the timing we consider, let's say this is a curve and point Q approaching to the point P, and you can see from here, let's say this is 3, a Q point is little bit after, so this is 3 plus h, the coordinate of this would be 3 plus h and 3 plus h square. So this distance is h and this is 3 plus h minus 3 is nothing but the h. 3 plus h square minus 9. So we can find the gradient of the point PQ as 3 plus h square minus 9. The difference between the point Q and P, which is this one, and difference between the point of P and the Q between the x coordinate is h. So you can simplify, you will get 9 plus h square plus 6h minus 9 by h. You can see from here we can write h common. 6 plus h by 8, it is nothing but 6 plus h. If you are moving towards the downward, means h is a positive number, you can take it 0.001. So the slope will be 6.001. If let's say you are taking a point here Q, you are moving toward this direction, so you can choose h with negative, let's say. So the slope will be 6 minus 0.001 means 5.999. So the more the closer the h, the more the closer the value of the slope near to 6. So it means this method is called ab initio method. First principal method or by definition, all have the same meanings. So now we solve one question to precise the idea. So student, we are given that the function f of x is x raised to power 5 and we have to find its gradient. So you can consider f of x is x5 which is given. Consider the function a little bit after its value. You have x plus h raised to power 5. So the gradient is defined as f of x plus h. Actually the point here is px and f of x, which is x5. This point is q, which is x f of x plus h x. So you have y2 minus y1 x2 minus x, which is over h. So you can write from here, open with the help of the binomial expansion, you will get x5 5x4 divided by dh. So you can write it as 1 by h minus f of x, we have to evaluate, which is minus x5. It will be balanced. Take common h from the numerator, you will get it will be balanced. O of h mean higher power of h is included in the remaining term. When the point q approaches to p, h approaches to 0 and you have h approaches to 0, these all term containing a power of h. So when you substitute 0, it will be 0 and we have only 5x4. This is your answer. So it means the gradient of the function f of x is 5x4, or in another word, the gradient of x5 is 5x4. So you can see that you can write the gradient power times 1 less. So in general, if we want to write, we can write it as the gradient of xn is equal to nx n minus 1. So I hope so you have understanding with this lecture, but if you have any problem or a question related to this one, you can contact on our WhatsApp number. See you again. Allah Hafiz.